Thank you very much, and good evening and welcome everyone to the StrawBale UK online event. We are very privileged this evening to have George Mikurcik from the old Holloway site, his own home based in England. And it was the first straw panel house made of Ecococon straw panels. What I'm going to do is start proceedings is to just give you a rundown, a background check on StrawBale UK. So we started off as a group of StrawBale builders, essentially practitioners, designers, academics, enthusiasts, and trainers. Our intention was to spread the good word of straw bale building. This was back in 2015. Since then, we've been exhibiting and attending courses up and down the country. Specifically, for a couple of years running, we were exhibiting at EcoBuild, the construction event that takes place annually in central London. We have also set up our own gathering, otherwise known as the Big StrawBale Gathering. That was led by Jeffrey Hart, who some of you know already. This is also part of the other events that we participated in and delivered on, more specifically the Upstraw projects, as you can see on this particular slide. This ran from 2017 to 2021. The intention of that project was to promote straw building to the public sector. And as part of the outcomes from that was the first EPD for straw building, or straw as a material, and the technical guide. We also hosted or co-hosted the ESBG 21, which was and still is an event that takes in countries from all over Europe. As you can see, Estonia, Germany, Slovakia, Poland, Switzerland, and France, Austria, Netherlands, and Spain, and Denmark and Italy were all part of that particular event. We've also contributed towards government policy, more specifically provided evidence for the government, and in this particular case, the reducing emissions in construction and education. Our members contribute towards education around the country. This particular slide is illustrating the work that Andy Bayliss and Kit Jones. Andy Bayliss actually is a student of that particular course, but Kit Jones is one of the tutors at the Centre of Alternative Technology, which is based in Wales. And also, our intention, endeavours are to make straw building more accessible. So what we are intending to do is to really broaden out and promote STEP, which is the StrawBale training for European professionals. It's an online course and practical course, and we're endeavouring to deliver on that as soon as we can. More recently, we delivered on events much similar to today. On one occasion, there's a Miscanthus, which took place in July with Fabrice Numagua. He's a civil engineer who was at the time a research student. He's now qualified from the University of Exeter. Thank you very much to Pete Walker of the University of Bath for facilitating that particular event. We then went on to, a couple of months ago, to host Joe Giddings, who spoke about timber and insurance and the similar issues and problems that low carbon materials are finding in the construction sector in the main. And this is what Joe spoke about. So, if you want to, please, we would encourage you to join StrawBale UK. We're a friendly bunch, we're very open-minded. and we're willing to look at your research if you're students or even a tutor, and also share your practices, share your projects with all to the industry. Right, so without further ado, I would like to hand over the controls to George and his discussion tonight about the old Holloway and a straw panel house. Over to you, George.
Thank you very much, Cyprian. So thank you for the invite, and good evening, everyone. Yeah, really glad to share our story. So this is Old Holloway, which is our home of about 6 years now, based in Herefordshire in England on the English-Welsh border. And oh, there we go. So some key stats. Yeah, completed in 2017. It's a relatively modest house of just under 100 square meters, built on a modest budget, which came in under £1,500 a square meter, and it was a proper team effort. We're lucky enough to have a really good team of Mike Whitfield, the main builder, who's very experienced with delivering passive house and low energy buildings, and also Nick Grant and Alan Clark on the kind of passive house and energy side of things. So this is where we are, Hereford, near the Welsh border. It's quite important for us to find a plot that was quite close to kind of place of work and within cycling distance to the nearest town and facility. So the site is the southernmost circle here. Place of work is about 3 miles away, and Hereford is about 5 to 6 miles away from us, so all within convenient distance. We previously used to rent an old stone cottage, which was uninsulated, very inefficient, cost an absolute fortune. That was kind of the other side of the woods. And then when an opportunity came to look at a site, yeah, we jumped on the opportunity and yeah, found this really beautiful plot. So very briefly about the site, it's in a village environment. The plot was previously used as a kind of a base for a shoot hut, local pheasant shoot, which is a bit strange, but there we are. So it's south-facing slope with really long views across Herefordshire, like towards Forest of Dean. Pretty unshaded, so yeah, quite ideal really. A few neighbours to the north, but yeah, quite a sort of quite a good distance from the site. So just in terms of the approach to design, we basically tried to sort of keep it low profile, trying not to obstruct the views of neighbours, but locate the building along the north boundary of the site to take advantage of the southern aspect and sort of locate the gardens, and basically make the most of the site itself. There were existing outbuildings on site, which are sort of along the south and eastern boundaries. So we basically retained those. So it kind of forms this informal courtyard, which is quite typical of Herefordshire. Just a couple of images. One on the left was previous site, and the one on the right was a photo montage for planning, just showing how the three buildings would kind of work together. So just going to the design. So it's a single-story house. We call it a bungalow. So part of it is fairly open plan, but it's quite a flexible layout. So it can function as a 2-bedroom house with a study or an office, or it could be turned into a 3-bedroom house with a bathroom and a shower room. So the central part of the house is open plan kitchen, dining, and living room. That's where we sort of spend most of the time, and then bedrooms. Bedroom wing is on the west side. We've got bathroom in that quarter as well. Utility, where we've got most of the services, is between bathroom and a kitchen, and study is on the kind of east side of the house. Section. So section is quite simple, really. We've got a fairly traditional pitched roof. Kept it quite low, again, to kind of minimize the impact on neighbors. But what we did with the inside is kind of open the ceiling, so it's not like a traditional sort of bungalow with flat ceilings, which kind of feels quite oppressed. We sort of opened the ceilings up, and it feels a lot more spacious inside. And yeah, the elevations are really simple, kind of taking cues from local vernacular, from the kind of agricultural buildings, from barns. So yeah, kept it really simple and kind of low key to fit in the locality. We've thought really carefully about kind of comfort as a kind of key items for passive house. Obviously, we've got large roof overhangs that provide good shading in summertime, and also provide sort of good sheltered feature for kind of extending the living space to the outside. Obviously, being a passive house, we have central ventilation with heat recovery. Glazing is triple glazed, so all the usual things that are kind of required for passive house. High levels of insulation, good air tightness, good shading. The key services are the main space heating is provided by, or used to be provided by, wood stove, a small 4 kilowatt wood stove, which we actually don't use anymore. And we have 2 towel rails in bathrooms that are fed off the hot water cylinder. The hot water cylinder has got a small air source heat pump integrated in that, so it's kind of internal. So all quite sort of modest, very optimized kind of services. So once we moved in, the first winter, we had bees from the east, and it was a real good test of performance. I mean, it couldn't have been kind of more extreme, but the house performed really well. We needn't have worried about whether it's going to keep us warm. It was really nice to actually be hunkered down and really comfortable inside. It kind of snowed in for a few days, but it was absolutely fine inside. And a few sort of initial shots from the inside. So the main picture shows like a winter scene with low sun, really sort of penetrating into the building. So plenty of daylight and solar gains through the glass. And the frost you see on the bottom right picture is actually on the outside. So that was quite surprising to see. Well, not surprising if you're sort of building visitors, but first time you see that, you kind of think, oh, that's interesting. But it's actually on the outside, and it's totally normal. So here we have some graphs of temperatures during kind of summer heat waves and beasts from the east. So heat wave on the left-hand side. Sorry about the kind of resolution, but the blue line, just where the kind of sun is, that's the internal temperatures. So all very even, sort of hovering around 20 degrees. The red line is the external temperature. So going up and down quite a lot. but yeah, it just kind of shows that the building performs really evenly, kind of almost whatever time of year. And then the graph on the right hand side during the winter and beast from the east, again, just kind of shows how even the performance is. And a more recent graph from last summer during the week of August, second week of August. Again, in red, you see the external temperatures going well above 30, but internal temperatures kind of keeping well below 25, which is kind of the best practice for passive house and for comfort. So yeah, when you're sort of outside and you come in, it kind of feels like you're coming into an air-conditioned house. But yeah, there was no air conditioning installed at that time. Right, on to the exciting bits. Straw. So as Cyprian mentioned, we used Ecococon timber straw panels, prefabricated panels, as the first project in UK. So we're a little bit of like guinea pigs, and the main reason for that was, I mean, I love straw, I love natural materials, but for me as an architect, I had small reservations about the kind of accuracy and just kind of buildability. There's a certain element of wobbliness about normal straw bales, which I wasn't quite comfortable with. So this prefab system provided us a way of kind of squaring that circle, and it really allows for really quick installation. It's yeah, it goes together really quickly. So yeah, we're happy to kind of give it a go. So just to explain how the system works. So building is designed as you design a normal house, and then the walls, external walls, get panelized by Ecococon, which basically means it gets turned into a series of individual panels, which then sort of get manufactured and go together on site. So this image shows all the different panels at the design stage. And here we have some key details. So we've got a foundation detail on the right-hand side, which is basically an insulated concrete raft. So part of the kind of passive house approach is to eliminate thermal bridging. So you'll see we are wrapping the concrete around, all the way around with insulation, and then the insulation upstand meets with a straw panel. So there are no thermal bridges here, effectively. So what it means is that there are no cold spots on the internal face of the construction. And on the left-hand side, we've got a roof verge detail, which is basically where the wall meets the roof. So the straw panel stops just below the roof, and then the roof is made with timber I-beams, which are then insulated with warm cell, which is recycled paper. It's probably quite useful to talk about air tightness a little bit. So typically the air tightness layer on most of probably UK projects would be on the internal face of walls. And yeah, probably some of the kind of typical straw bale or traditional straw bale projects would have that on the inside. But in our case, the strategy is for the air tightness to be on the outside. So we've got a breathable, well, it's vapor open, but airtight membrane that is wrapped on the outside of the panels, and then that gets switched over to the underside of the roof. which is a different type of membrane, much more sort of vapor closed. But this means that any service is kind of running in the plaster. We don't need to worry about air tightness and kind of leaking, because the air tightness is dealt with by the membrane on the outside. And then there's additional wood fiber board, it's about 60 mil in our case, that kind of provides additional insulation and kind of eliminates any remaining thermal bridging. If we go to the next one, we've got a typical kind of window installation details. Good practice to kind of put windows in the middle of insulation, which basically minimizes the thermal bridge, installated thermal bridge, and actually the reveals at the head and sides provide some good useful shading as well. So a few photos from the construction itself. We used a pre-fabricated insulation under the concrete slab. So this was Ecococon system. There are others on the market, but again, it was a really quick way of doing foundations. We poured the concrete in, and then it was sort of ready for the straw panel delivery. So this came from Lithuania on 2 lorries, was unloaded fairly quickly and stored on the slab. And you see the panels here wrapped in some sheets, polythene sheets, which is obviously very important to keep the straw dry during the construction, because straw and water don't really go well together. So yeah, we were really careful to kind of keep them dry at all times. And then we started putting it together. So you basically start in one corner and kind of make your way around the perimeter. Really easy to get together. Each panel has some pegs for easy location, and yeah, it's a really low key way of building. Not many skills needed. It's also a very dry site as well. It wasn't always this sunny, I must say, but yeah, the walls came up really quickly. So I think in 3 days, all the external walls were basically up and covered. It's down with this big persuader. I think we really enjoyed that tool. So here was Paula installing the air tightness membrane on the outside. So that basically gets installed pretty much once the panels are in place to provide instant protection on the outside. And then we put an extra sheet of plastic to the inside face to keep it protected before the roof was on. Here was the aerial shot. So as I mentioned, the roof was constructed using 450 mil timber I-beams, and then the zone where we got the veranda, that was a combination of 200 mil I-beams and some solid timber joists, which then cantilevered out. Couple of shots of the foundation. So this is the external side of the panels where the DPC meets with the membrane. So that's kind of before and after. So important to obviously get all the air tightness layer sealed up properly. And there's only one shot at this. Once you put the wood fiber on, you have no access to this. So really need to be meticulous about kind of sealing these layers. And this is how the panels kind of looked from the inside before the windows were put in. So all the window and door openings were lined with plywood. So plywood provided good fixing background, and also it's kind of inherently airtight. So it was quite a straightforward way of sealing the windows to the panels using the plywood reveals. Here we got a seal between membrane that comes from the outside of panels under the roof, and then would join the membrane under the roof internally. So there's a bit of a step in. Windows were sort of pre-taped before installing in place. It's much easier to do it when it's horizontal on a bit of a stand. As I mentioned, the roof was insulated with warm cell, so I think we spent about 2.5 days putting about 6 tons of paper in the roof, which keeps us really cozy. At this point, we did our first air test. So that was done at a stage where all the kind of straw panels were exposed on the inside, and the air tightness membrane was exposed on the roof. So we could kind of hopefully identify and attend to any kind of leaky areas. But the most leaky bit was actually the wood stove, although they were claiming it was airtight. Yeah, that was the source of most of the leaks. But our initial air test was about 0.4, so we're quite happy with that. 0.4 air changes. Yeah, Nick here kind of checking the big sliding door, which is the usual kind of source of air leaks. But the door was fine actually. And then, yeah, we carried on with kind of internal lining. So my brother came over and gave us a hand with installing linings on internal partitions. So we used Thermocell boards for kind of extra thermal mass, which I think was a really good decision actually, because it really makes a difference, not just in terms of thermal mass, but also in terms of acoustics. It sort of really increases the performance. And then Dad helping out with the ceiling, nice timber ceiling, so very grateful for that. But it's not all good news. We did discover a leak from before the roof was put on. So there was a temporary kind of plastic sheet over this area, but it wasn't fully sealed. So for about 3 or 4 weeks, we had this kind of weak spot that was leaking into this panel, and it started sprouting up. Surprise, surprise. And it was really wet, like 40% moisture content wet, and it just wouldn't dry out. I had a big fan pointing onto it for about a week or 2, but it wasn't really moving anywhere. So the best thing to do was to get rid of the straw, wet straw, let it dry out a bit, install some wood fiber boards, and then insulate it with warm cell before it was clay plastered. So yeah, I think it's just really, good not to sort of paint an ideal picture about these things. Sometimes things do go wrong, things can get wet, and sometimes you just need to replace a bit of panel and put a different material in. It's not the end of the world, and it can be rectified quite easily. It can be, yeah, totally fine. If you need a new service penetration through the wall, just get this chainsaw out, cut a new hole, but don't forget to seal it up. So sealing was obviously really important for any penetrations. So here you can see a new duct through the external wall, but properly sealed up. Then the missing bit of wood fiber was reinstalled again. So all the timber elements of the inside, we had to sort of install some reed mats before plastering. That was to really provide a good key for the clay plasters. And then Roman was our Slovakian plasterer. Yeah, he started with plastering, clay plastering. So obviously that's an ideal material for inside, and it was applied straight onto straw. straw panels. So it is something, that we recommend as a complementary material to the Ecococon straw panels. So we used about 1 inch of base clay plaster in kind of 2 layers, and then 2 top coats of about 1.5 mil each. And we used reinforcing mesh between first and second base coat, which you can see here. And then on the internal partitions, we had 1 thin base coat and I think 2 thin top coats. So here you can see the base coat being over plastered with the top coat. And some very fine Japanese trowels to kind of finish it off. And that's the kind of finished finish, which is really quite beautiful, and just gives us joy and pleasure every day. One thing about, well, you all know about clay plasters, how well they kind of affect the internal environment. They're all non-toxic. They help sort of buffer the moisture, etc., etc. And it's all self-finished. There are no paints required afterwards. A few shots of the finished house. It's the main kind of living space with Midge's favorite sitting spot on the chair. That's the room where I'm speaking from at the moment. That's the home office. And the outside. So you'll see this external sail, which we sometimes put out. The main purpose of that is to provide shading for the deck rather than the house itself. It's just nice to sit outside. A few thermal imaging shots, just to see if we can spot any kind of cold spots in the house. But the coldest parts were, I used this cold beer bottle just for reference. And I think Midge's nose is quite cold on that top left image. But yeah, generally speaking, very few thermal kind of cold spots around the house. It was all fairly even, as expected. And a more recent addition to the house was a PV system. We kind of intended to put it, install it at the beginning, but kind of slightly ran out of cash, so had to wait a bit. But yeah, was spurred on by the energy crisis last summer, so this went in together with a battery, and that has really kind of reduced our bills quite significantly. So yeah, this was I think our October or November bill, which is about £30. Yeah, really recommend that. And we also retrofitted this small mini split unit. So that's a small heater and air conditioning unit, 2.5 kilowatts, Mitsubishi, and which now that means that we don't really need to use the wood stove anymore. This small unit can actually heat the whole house, no problem at all, and provide some useful cooling during summer as well. Just for information, we open the house at least once a year for Passive House Open Days. So if anyone would like to come and have a look, sign up. It's usually in June and November. So yeah, people will be very welcome. And a few kind of lessons learned. So thank you very much.
Brilliant, well done, George. You've managed to fill a lot of information, do all of your slides, and we've still got about 20 minutes left for questions. So if it's all right with you, Cyprian, I'm going to go straight in and pick up some of the questions. So yeah, let's see. So early on in the presentation, Hugh was asking exactly that question. What heat source do you use now instead of the wood burner? So I think that's answered your question, Hugh, but do you want to ask anything further? You can unmute yourself. If you're there, Hugh.
I would just say most of the time now we don't actually have any heating on. We put the towel rails on, so they are running during the winter time off the hot water cylinder, but we rarely put anything else on, to be honest. Okay, fantastic. Debbie was asking, what skills do you need in the project team for Ecococon when you're doing Passive House as well? Is there something, Debbie, you might want to add further flourish to that?
Well, just the, what are the, I mean, you had access to so many wonderful people, but if somebody didn't, what would be the key skills that would be needed?
I think just having a Passive House consultant on board. I mean, if people are not skilled in Passive House design, just get someone who's done it before. I mean, Ecococon as a system is actually a certified Passive House component, so it has all the certificates. It's basically suited for that purpose. So you kind of halfway there if you use that system, but you obviously need to make sure that all the other elements of the build, like the foundations and the roof and all the junctions, are kind of designed in a way that eliminates the thermal bridges. But yeah, it's relatively easy, I would say, as systems go. There's nothing to kind of be worried about.
And the builders?
Well, we're lucky because we've got Mike here. But to be honest, it is designed like a big Lego, so it just kind of comes together quite intuitively. You don't need many skills. It's not a bit like being a brickie that you need to be skilled in doing that. It's literally people with impact drivers and some ratchets. That is it. The panels come all color coded, so you know exactly which panel goes where. You just start in one corner and just kind of make your way around. Really easy, like IKEA furniture kind of thing.
It looks fantastic. Hugh also asked about what type of insulation was used on the foundation slab. We saw a picture of it then.
Yeah, that was that pink EPS, wasn't it?
Yeah.
Yeah, polystyrene.
Yeah. Did you have a go at laying it, or did Ecococon do it?
It was actually our ground workers and Mike. Yeah, so they just did it. Yeah.
It looks really good.
And I think Ian Hatton also asks, did you consider an alternative to the concrete foundation?
Well spotted.
At the time, and due to the timescales, we didn't, because we got the planning permission sort of in about February time, and we needed to start really quickly. So although I kind of looked at a few alternatives, this was the kind of the most straightforward and quickest way of dealing with foundations.
Right.
But if we're starting to build again, we'd probably look at some kind of concrete free alternatives. Yeah. On the other hand, the concrete does really provide this good thermal mass in the house, which kind of balances out the relatively lightweight walls. So I think it really contributes to the kind of even temperatures in the house.
So picking up a few more, Wabi Isaac says, how is the fire hazard dealt with? I mean, for those of us who are slightly long in the tooth with straw, we know how non-combustible straw is, but
So
do you have any tricky?
That's a good question, but there's a very simple answer. The straw is covered in inch of clay. An inch of clay provides about 2 hours of fire resistance, so it's perfectly safe. And also the the density of straw in the panels is about 130 kilos per cubic meter, so it's much denser than your straw bales. And being so dense, there's so little oxygen that it's actually really difficult to set it alight. So yeah, it's super safe.
I think we've got some clips from situations where Barbara's tried to get fire officers to set fire to straw bales somewhere on the SB.
It's hard work.
website.
It's hard work.
It's hard work, yeah. So there are quite a few questions about just moisture during the build. How do you keep all the panels dry once you've started to build? We saw them being covered with tarpaulins.
Yeah, we just kept covering them up.
Yeah, and obviously, as you showed us very generously, doesn't always work.
No, that's it.
What made you go for the straw panels over I-joist in the first place, instead of using I-joist and warm cell? That one's from David.
Well, I was just really intrigued because I mean we've done projects with I-beams in the past, many of our projects at Archetype, but I was just really intrigued by straw. You know, the combination of straw and clay plasters is a kind of really good combination for kind of healthy material. Whereas very often when you use timber I-beams, with warm cell or whatever, you kind of end up with a service zone and plasterboard as your internal finish, and it just feels really quite hollow and like it. I don't know. There's something about this kind of solid clay plaster and straw that feels like a proper house.
Julia,
not to diss, I-beam timber frame houses, but it is a different feel. It's definitely a different feel.
Yeah, well, it's your house.
I'm going to just as you're going through the next round of questions, I'm going to launch a poll. It's a very simple one, just to ask the delegates if they have built with straw, constructed with straw. I know a number of people on this particular call this evening, but there are a number of which I don't. So I'm just going to launch that now, and if we can just progress with the questions, all of you should be able to see that. And let's keep it going. Let's keep the questions flowing.
Okie doke. So Tom was saying, why was the external wood fibre necessary? And he says, I guess it was at 14.9 kilowatt hours per metre square per annum heating demand. Or was it because a conservative lambda value was used? Was it before we had the EPD?
It's the answer is it's part of the certified system. So it does improve the overall U value, but also it sort of moves the dew point further to the outside. So there's a reason for that.
And Clive, who I know is going to be doing a straw cottage himself this year, could you talk about the Fermacell boarding versus other considerations? 30 mil clay plaster applied directly to the straw cassettes. So I think you were showing Fermacell on the internal walls. Yeah,
Fermacell was just on the internal partitions, which were timber frame.
And versus other considerations, so versus straight old-fashioned plasterboard.
Well, again, plasterboard, I was just not very enthused by using plasterboard as a kind of background for clay final finish. I think the Fermacell is quite textured, and it provides a really good key for clay. Whereas I think with paper finished plasterboard, it probably wouldn't be so easy, and it would be a lot lighter as well. So we just kind of wanted to add a bit of thermal mass. So yeah, it was multiple kind of reasons for that. And it's better kind of higher recycled content in Fermacell as well.
Yeah, and it's got a bit more structural rigidity, hasn't it?
Like fixing anything to Fermacell, we can just, I can probably hang myself on one fixing. It's so strong.
So you showed us a picture of a new duct going through the wall. Why was that required, or was that just the standard way of installing the MVHR through the wall? So
that was basically done during the build, but at the time we didn't quite know where the duct would go from the internal unit. So we put the unit in place, and then we put the duct through the outside. So rather than sort of trying to guess where exactly the duct would go, we just cut it out when we needed to.
And what else can we see here? Was it tricky putting in the heat pump when you were retrofitting it, trying to maintain the air tightness? Or nope. I mean, you probably knew that there was not so...
we just removed the cladding on the outside. It's obviously wood fiber, so just cut a little square in the wood fiber carefully, and then cut a new opening, which is basically like a 80 mil diameter hole. Put the conduit through, sealed it all up. So yeah, that was quite straightforward, really. And
did the heat pump alter any of your behaviors? I mean, I don't know how long you've had it in. For example, night purge ventilation. Tom, maybe you just want to open up your mic and just explain that question a little bit more.
Sorry, my family's still asleep. Can you hear me?
Yes.
All right.
We got you.
Wondered if it's tended to change your behaviour and how you run the building just because you've got the benefit of air conditioning. Or actually, you don't tend to use it much.
Well, we had it put in last September, so it was kind of after the main heat waves. So we haven't actually used the air conditioning much. We've mainly used heating probably half a dozen times or something like that during the winter, like this winter. So we're waiting for next summer really to test it out.
Okay.
But I don't expect to change behavior, to be fair.
Yeah. Someone's just joining us. There's loads of questions come into the chat whilst we've I start to feel
I've got a question. Not so much technical, albeit it's planning. George, one of the first images that you put up on your presentation was regarding the impact on the neighbours. Yes. Did you face much in the way of objection to the build?
In theory, no, but we had one very wow, how I would describe that, interesting neighbor who didn't object face to face, but when it actually came to planning, there was a campaign, so it actually ended up at the planning committee, so we had to kind of defend and have a speech and all that. So
yes,
but yeah, he kind of sailed through because there were no grounds to object.
Okay, thank you.
Well done. That's not an easy situation. Sometimes it's very difficult to say what you want to say face to face, isn't it?
Yeah.
So I'm going to try and pick up a few of these, unless we just want to open up the mic, Cyprian, and let people.
No, just go through. But bear in mind we have 6 minutes left.
So Hugh said, "Did you feel the roof overhang at the rear should have been deeper?"
No, not really. I mean, we had, it was about a foot of an overhang.
Yeah.
Is that on the north side?
At the rear, so on the other, on the north side.
Yeah. So the gables and the north are about a foot kind of overhang, and that seems to be enough. Yeah.
I think maybe it was just when you were showing us the picture of the air source heat pump that it looked like the timbers had a bit of kind of green.
Yeah, but that's
painstakingly charred timbers.
That's the north side. I mean, that would get green, whatever. Yeah. It just doesn't get the sunlight.
Thank you, Hugh. I did pick it up right. He hasn't got a microphone, he explained to me. Undala, welcome Undala. Nice to have you here. What made you choose Ecococon over Modcell?
I just think it's a much better product.
Okay. He's now a rep for Ecococon, everybody. So, you know, you weren't really going to get any other answer there. What did you see? Sorry.
Hi, it is Undala. Hi, George.
Hello.
I was asking more in terms of the spec and stuff, but you said it's a better product. Is it because it's more? Why is it a better product?
Well, it's I think Modcell is basically based on really long bits of solid timber as a frame, whereas Ecococon panels are separated. It's basically a twin stud panel, so it has 4 bits of timber in each corner, and there's very little timber kind of joining the outside and inside to really minimize the thermal bridging. And also the density of straw is much higher compared to mold cell. So it's I think it's a, that's why I think it's a better product. It's not done sort of on a factory floor with people kind of stuffing the straw into the frames.
Excellent. So I'm just trying to see, I think probably we're going to overrun. So if there are people who've got questions I haven't covered yet, did you consider alternatives to the plastic insulation that it's EPS? I think you mentioned that you probably would have looked at a non-concrete, non-plastic.
Yeah. I did actually look at foam glass gravel before, but for the U values that we needed, we would have ended up with much deeper kind of foundations and the excavation. So it just, yeah, it was cost prohibitive.
Yeah, it becomes swings and roundabouts.
Yeah.
Clive says, do you think being a passive house added much to the build cost? I mean, you're a passive house designer, so you probably didn't even think of not doing it that way, but
I had to do it. We had to do it. We had to do it. It was our planning condition to do it as a passive house.
But in your current sort of, is it fair to ask you, do you feel that passive house adds much into the cost part of it?
I don't think it would if it's designed right from the beginning, if you know what I mean. So if that's what you're doing from the start, I don't think it adds any extra cost.
Yeah. Kit's asked a good question about the external air tightness layer. Mm-hmm. Why is internal moisture getting into the walls not an issue? So because you stepped the air tightness up the outside of the walls and then brought it into the underside of the ceiling, is that right?
Correct, yeah.
So was there a vapor check to prevent internal moisture? How does that work?
Well, the clay is almost your vapor check. I mean, you've got an inch of clay. That's quite a good barrier, isn't it? And that sort of helps regulate the moisture. It's not like there's like loads of water vapor going into straw, because it doesn't work that way.
So again, I'm going to race through these. So which external membrane did you use for the air tightness? I didn't check. Was it a Sega?
It was a no, it wasn't a Sega. It was what was it? I think it was one of the Procter membranes or Tyvek. Yeah, sorry, there was a Tyvek. Yes, that's right. Yeah.
Kitchen. I don't understand about the plywood thickness, but just for speed, kitchen extraction. Did you have a recirculating kitchen extractor?
Recirc.
So, Martin, I don't know if you've done passive house design, but you make sure that the kitchen dirty stuff is caught in the filter.
Yeah, that's right. Yeah, so we got carbon filter on the.
That's it. So that the MVHR system doesn't have all of that kitchen gunk.
The grease. Yeah, that's it.
You don't want it in your very expensive MVHR. In the roof, do you have the same thickness of insulation as in the walls?
We've got 400 or 450 mil of warm cell. Yeah.
Excellent. Are you using an Atatmo weather station?
We do. Yeah.
Yeah. Any problems with insurance companies? That's one that comes up, and we never know. We never know the full breadth of the answers on that.
No problems. No, it's a timber frame.
Yes.
It's a timber frame.
And Zeno has shared a link to a StrawBale house in Wexford. Tim has said thank you.
I think we're going to have to wrap it up, Julia.
I think so. Just one more question. Do you think the modular system lends itself to larger scale projects?
I hope so. Yes, absolutely. Yeah. I mean, the panels are kind of designed to work on mid-rise. So yeah, it could easily be used for mid-rise, high-rise. No problem at all. There's actually a small primary school in Denmark that's been built with these panels. There's also a sports hall, like two-story sports hall in Belgium or Holland. So yeah, it can be done. Absolutely.
Stop sharing all that one. Right.
Great. Thank you very much, George, and thank you, Julia, for fielding the questions.
I'm going to be really cheeky and just share that
Yes,
screen.
do, please do.
There's a free talk on Monday night with a link down there at the bottom, and I'll pop it in the chat, which is Tom Woolley talking about unlocking the barriers to the use of bio-based materials. So if you're interested, have a look on the Green Register website.
Yeah, if you could pop in that link in the chat, that'd be fantastic. So the results, if you hadn't seen it already, regarding our very brief poll, how many of you had worked or constructed with straw? 68% of you said no, and 32% of you said yes. I very much hope that this encourages you all to get involved and to ask those questions of the construction industry. It is very much needed as a material, low carbon, and as you can see, from what George has illustrated this evening, a very, very thorough material. So again, thank you very much, everyone, for participating this evening. If you want to ask any further questions, you can go to our website. And George, without further ado, I would like to say thank you very much for presenting a brilliant presentation tonight. Fabulous, and we look forward to working with you more in the future. That's it. Ladies and gentlemen.
Thank you for the invite. Thank you.
Thank you.
You're very
Great.
welcome. Thank you.
Great. Thank you. Bye-bye.
That's it. Good evening, and we will speak to you soon. Keep an eye out on our website for future events. Good night. Bye-bye.
Night.
Bye.
Thanks. Thank you.